Hello, welcome to this video. In this video, we will learn how to make a program that lists all directories and subdirectories of a path that you enter. So just click run, and first enter the folder path that you want to look. So for instance, I want to look for users that slash touch freelance slash document, and then enter, how many path per screen, how many entry that you want to look for display for a screen that you want to display it per screen. I want to create 5 entries, for instance. I will type 5 and then and then type enter. And this number of entry 57 folders, so you can go to that folder. And as you can see now, I am on C users top students documents, and I will select control A, and click, and then click over this, and this is the 57 folders, including the hidden folders. So this is, if I enter, you can see that its entry is its display is 5 entries. If the same as with this number, if you type this number 6, it will display 6 entries per group. So like that until it's done. So this is basically displaying all the folder all directories and subdirectories of a path. So for the code, this is a quite long but the process is simple. But first we need to display the banner, program to list all directories and subdirectories. This is the title, this will be the title, this is the banner. Welcome to program that lists all directories and subdirectories, and equal sign, and then uh, a text word line, and a new line. This is the new line on the fifth line. Now this is the loop of for if you if you want to continue, you just press enter on the end of the display of the last folders that displayed. So this is the fourth. This is the variable that we will use, and this is the n is 0 and f_all is 0. F_all is the length, L is length of the f_all variable. So first we will ask the question, enter folder path that you want to look, and then save to p variable, and then we ask question again to the user, enter how many path per screen, and then save the information to np, and then in the file we get files directed. We invoke a file dot get directories on the p and save it to file. And now file contain a folder that on the user slash dot freelance slash documents will contain in the file as array. Now the file uh, is equal a file. So this is the imagine this is the scheme, this is the image that you can help you to imagine the process. So the file content the content of file, this is array. For instance, file is content for directories or for elements of the array, and is copied to a file. This is the a file on the bottom. This is a wall, and it will copy it to do this and this and this. And now let's continue. While fall is not equal empty, while fall is contain something, have something inside the array, and we'll get array get item count false. So first we need the how many element or member of this array. We need the count. We need the number, and then that we just use that as an index for I a variable for I is equal 1 to fol. Fol is this the folder length. This is the L is length, and then we have we we have the get directories of this element, first element, and save it to the temp. So temp is contain the tree. Now is temp. This is get directories of this element, and it will display or result 3 elements. And then after that, we need a temp L or temp length, the length of the temp variable variable, and in this case we have 3, and then we need to temp to fall. We need to get item count of temp to fall in this we now temp to fall. This is temp to fall. So I'll pause the video. I'll fix this a little. Okay, now I have fixed this to temp to fall. This is temp to fall, and go back to the. We need to this time at this line the temp to fall is empty, so the temp to fall length is 0. So for now it's time to enter the content of each temp, this one to this temp to fall. So contain the this guy, this tree. Right. Okay. I will change this for instance. Right. So we need to change this three. We need to enter this 3 element to the temp to fall. So now this is the code. So and then we get the 4 again. We go back to this 4, and this time the I is 2, and we get the then we execute the next line, next line. We get file get the directories of fall 2. So we get this get directories of this element, and we have for instance 2, and then for the same we need to put the temp element members, this one, this 2, to this temp to fall array. So that's and then go back 4, and then 4 go back again, loop again, and then this time this third element of fall, we get the directories of the fall, and then save it to temp fall array, and then in turn we have put this to temp to fall, and this, and then the last fourth element of 4, the we get the directories of that the path again, and we have two, for instance, two folders, and then we put the temp to fall, and then when the this work done, we get we have 4, and this 4 and 4 is done. This one we continue to line 55, and we need to find the AFOL length. So this is AFOL, and we need to know the L length of the AFOL. For in this time, on this current time, the AFOL is length is 0. So the temp to fall will now the AFOL L is 0. So temp to fall, now you get the length of this temp to fall L again, a new measure, a new length, the last length, the recent, the newly length, and then we use that for j loop for 1 to temp to fall, and then put that temp to fall j to the I fall plus j. So basically this I fall is now 0, so j is 1. So we will put the temp to fall 1 to temp to I fall 1. So it basically put the temp to fall 1 to I fall 1, temp to fall 2 to I fall 2, temp to fall 3 to I fall 3, and temp to fall 4, and so on until the last to the I fall. So now I fall is contain this one. So this is the last. So and then we put fall to temp fall. So we put this fall to temp fall to this to move. So the temp fall temp to fall. I mean, so temp to fall now contain fall, and we increase the n. We increase the n to +1. So we need now we have a second level of the tree. and then we have while this is, and then while is looping again to the up, and then continue again now we need to the for L. So the length of the for L, we continue to length of the for L to measure to get the length of the for L, and then from that we now, okay, wait for a second. Okay, so you can see on this 62 line, the temp to fall values or elements is copied to fall. Now fall is have temp to fall elements. So this basically the before I tell that fall is copied to temp to fall, that's a fall, but temp to fall is copied to fall. So now fall contained the temp to fall, which is a new as members of second level of the trees. Now it will get each one of these directory and put in the temp, get this one the directory again, get this one subdirectory again, get this one subdirectory again, get this one the subdirectory again, get this one subdirectory, get this one, and get this one directories, and put the temp, and then put to temp to fall. So temp to fall is after we copy to fall, temp to fall is emptied, so it is 0. So that's how you can continue long and again until you deplete, until you have no subdirectories again, until it is until the end of the subdirectories or the end of the trees. So that's how uh, you can print you can search, you can list or learn subdirectories using this algorithm. And for next section is we need to print out the result by for group by each numbers that we just entered into the this this prompt, enter how many pad per screen. Though, so we save that. If we want 5, we save that to np. We want 5. So and for instance, np is 5. So now let's jump into this section. So if np is 0, so I will increment that, because if np is 0, it will end the program. So we need to if the if one. So if anytime the user use np is 0, I will increment that. So that's for uh, the 75 and 77 section code, and then for 79 until the 180 108, I mean, this is for I to AFOL step np. So AFOL, for instance, the last AFOL is contain 57 folders, just like our our first example of c colon slash user slash dot freelance slash documents contain 57 folders. Now it's time uh, to display it. So for e is equal 1 to 57 step, and p step 4 step is just so step 4 step 4 step 4 step 4. So if I plus np is equal less than I4. So if the I plus np is less than I4, is not exceeded the limit that is I4, then we just print out this one. So for j is 1 to np plus 1 minus I, we print a line I4 j, and n4. This is end of this for. And else if the else of this if I plus np is bigger than f-wall, the length, so it means there is a there's a padding, there's a redundant, there's a and so we need to print out from j to j. So we need to print the rest of the element of the element of the f-wall to the length of the f-wall. So from j equal I to f-wall. So for instance, we have um, 10 element and we step up 7. So if we until we have, so if we step 7, we increment that to 7 again, we will exceed the 10. It will result in 14. 7 plus 7 will 14. So if we still use this code, it will get a redundant element members, and it will print out empty line, because the element of member of AFOL is empty. And then we need to, so the for NP7 to 15 we didn't print 7, we just uh, from 7 to 10 we don't print 7 times, but we only print 3 times. So this is only print 3 times the rest of it. And if j, this is the for, this is the end for, and this is the end if of this if. Now this is the last if j is less than f-wall, press any key to continue. It will basically this is telling you that at the end of the j, we will from this, I mean, if the j is less than f-wall, it will keep saying you press any key to continue. So it will loop again, and this is an if. It will loop again n4. This is n4. It will loop again to this 4 to print out the next step or the next group of entries based on the step. So, and the three rest is just prompt a banner n, and a line on the 108 is go to up again. So this is the label up. So that's basically how we can uh, create a directory recursive finding. Thanks for watching and hope you like this video. And one more time, let's do another. Let's try. This time we try to go to users and touch freelance, and we try to obtain the directories of uh, pictures. Okay, enter. So uh, okay, let's dive in. Let's look for the pictures. So this is pictures. So what's the problem? I will post. Wait, I will post. Okay, we try one more time. This time we'll use the same the backslash on the end of the path. So last time we don't use the backslash on the last of the end of the pictures. So now right now we will use this backslash, and then I click enter, and then decide how many path per screen. For instance, in this time we say for 7 group or 7 entries per display or per screen. So this processing level, you can see there is a 26 folders, and there are 3 levels, and this is the entry. So you can see 1 2 3 4 5 6 7. There are 7 entries per display. So if you click, if you enter again, you get another 7. You get enter again, you get another 7, and then that's the end. Okay. Uh, uh, that's for this is a little bit. We need to modify this a little bit. Okay, we need to erase this. Oh, wait a minute. Okay, here we need to erase this. So we will continue keep the same. So let's learn again, and then we use the same path before. And then click pictures, and then 7, and then you get the same. Okay, get the same. There is no new line on the end of this. Okay, I hope you like this video, and don't forget to subscribe, like, comment down below. Thank you.